So the play blast is done. I have it up here on the screen, and let's take a look. So we have a few areas that we obviously are going to have to address. I'm not really liking the way it's making contact with the size of the container. I may have to go back in and adjust some auto resize settings regarding my boundary X, Y, and Z. But let's scroll up to the top, and here you'll find the auto resize threshold. And this is a very interesting setting, and I pulled up the help docs because this is pretty tricky. This is going to solve a lot of problems or artifacts that are going to be appearing at the boundaries and edges of your container. So once I pull this up and really explain to you how this works, you'll have a better understanding on how to apply it to your simulation you're working on. So basically what this essentially is doing is it's going to resize the density threshold, setting the density value that causes the fluid container to resize. So basically as you increase this value, the density at the container boundaries are going to increase. So I try to keep my values at very low values at 0.001 or even 0.01, or sometimes I just keep it at 0, so that way I'm forcing my container to try its best to constantly provide room for my smoke and density as it expands. So I'll go ahead and just give that a value of 0. I'll scroll in here a bit. And what I'd like to do now is take a look at my boundary settings on my grid. So let me select my grid. Let me go on my attribute editor. And let's scroll to that section. So right now let me quickly explain to you what each boundary is going to do. None basically just makes all boundaries of your fluid container open, so that the behavior of your grid acts like the boundary isn't there. When it's selected to both sides, this closes both boundaries of the fluid container, so they act like walls. So essentially what I'm going to do now is I'm going to disable resize closed boundaries. So when on, the fluid container resizes along the axis that have their respective boundaries attributes set to none, both sides, negative side or positive side. So that's a cool little trick that I like to use. I like to utilize this feature in conjunction to whatever boundary setting that I have applied. So it's all up to you. Once again, I turned that off. So now if I rewind and go back to the top, and let's take a look what it does. So you notice Z is locked into place. Z is not moving. We have it set to none. So essentially that's acting like the boundary isn't there. Now if we were to resize, if we were to turn that resize option on, the behavior of our grid will change. So this is a good way to allow extra room for your grid if you feel like your smoke is collecting on the sides and the auto resize threshold parameter wasn't a success. This is a pretty neat way to help out and assist your smoke when you're simulating. Now us turning boundary X to none, notice how that's behaving. So now you can see our grid is conforming to our smoke nicely. And that's all by just changing our boundary X to none, and the same goes for our boundary Z. Our Y is set to both sides, so notice the Y is going to be locked into place. It's not going to be moving at all. We just have our boundary X and our boundary Y Z set to none. So let's go back into the perspective view, and you'll notice all that extra room we have. That's very good. Now let's go ahead and change the boundary X to negative X side. And the reason why I'm doing this is because you'll notice when we press play, you see how the back of the grid conforms immediately to the fluid, but the front portion stays locked in place. And that's exactly what we want, because we're only concerned with the fluid that's in front of the camera. So if we had any problematic areas where our smoke was clipping the front of our container, this is another solution. And a trick that I like to use is by me just locking my negative X side. That allows all that extra room that we see there. Keep in mind it will add to render time, because we're adding more calculation data, because the size of our grid is going to be bigger. But it's definitely worth doing, and I recommend you doing it if you have a very high detailed simulation that may just need the extra room. Definitely go ahead and enable that feature, and it sure will avoid any problems. So I went ahead and enabled my velocity draw. Let's go ahead and change the draw length to a value of 0.5. And I like to do this. You don't have to go ahead and enable it, but I like to go in and see how my voxel data is behaving. I normally go ahead and play it while it's activated, just to see the direction of where they're going in the actual motion of my fluid. So let's disable that and scroll around here a bit. Scroll back up to the top. I think I'm going to turn my boundary X back to none, because what that's going to do is it's going to save us a little bit more render time when we simulate. But for the final render, you can turn it back to negative X. But what I would recommend to do first is test things out. Play the simulation, render a low resolution pass, see how it behaves, and if you see any clipping or see any artifacts along the edges, then go ahead and make the adjustments to the appropriate boundary sides. But for right now, let's keep it at none for both X and Z, and move forward. What I'm going to do now is select my fluid container, shift select my drain, and under the fluid effects menu, scroll down and select make collide. Now the geo connector will pop up in your channel box editor, and just type these values in: 2000 for the tessellation factor, 0.2 and 0.2 for your resilience and friction, and you should be good to go. So let's do the same thing for the floor. Select our container, shift select our floor, and under fluid effects menu, same thing, select make collide. We're going to give it the same values as the drain geometry, but if you don't want to have to keep on typing in values like this, you could just go into your option box, make collide option box, and type in your values here. So every time you would make this connection with your container to a specific piece of geometry, it would instantly save the data you put in your option box. So that's a pretty neat thing to do. Sometimes I like to do that. It's all up to you. So I'm just panning around a bit. Let's select our floor geometry and hide that. And let's rewind our simulation and see how it's behaving. And nice. This is exactly what I was looking for. As you can see, you'll notice our smoke now is colliding with our geometry, creating that nice pattern. It's breaking our smoke up. Now we're getting different shapes for different forms. Some areas are taller than others, and that's exactly what we want. If we didn't have that piece of geometry there, our smoke will just be too uniform and too consistent as it's rising. So if you guys are familiar with Chicago and New York City, I'm from New York City, but it gets very cold. It gets very cold during the winter season, during the holiday season, and normally if I'm in Manhattan or just in my neighborhood, I'll notice the sewers. You'll see that steam that just rises up, and because of the pattern that it creates, you see different shapes and different forms, and it just looks pretty cool. So that's exactly the effect we're going after, and that's what that does for us. So right now I'm going in, I'm selecting my emitter, and we're going to go ahead and key some density values here. By keying the density parameter under your fluid emitter. The good thing about that is we're going to be adding more variance, and now we're going to be breaking up our shape even further. Yes, the drain is doing a pretty good job of breaking things up, but now if we create a pattern and we animate our density a long time, that's just going to add a little bit more realism for us, and that's great. So we'll key that value at 6 at frame 1. Let's move to frame 5. Let's key it again at 6. And let's go to frame 10. And let's give that a value of 1. And what we're going to do here is along 5 frames, matter of fact, we'll give that a value of 2. What we're doing is along 5 frames, we're going to keep that value at 6, and then from frames 10 to 15 we're going to keep that value at 2. So I keyed it again at frame 15. Now we'll change this to cycle. First, let's turn on infinity under the view tab, and this is the pattern that we get. So if you're not too familiar with the post-infinity curve, what this is going to do is just repeat your animation over the course of your frames. You don't have to go in and manually key it. So I'm just right now just going in and I'm testing things out, and oscillate looks pretty good. Linear, that's what cycling with offset looks like. If you want to go to see what linear looks like, that's what that looks like. Let's go back in and select the constant. So you can go ahead and decide what technique may work best for you. If you delete keys, you get different patterns. So go in and be creative and have fun with it, adding in different values. Obviously, if you utilize a specific technique, it's going to change your simulation drastically. But I'm just going to keep it on oscillate like this and move forward. I like this pattern a lot. It's going to work well, I think. So we have it over time, just gradually changing from the value of 6 to 2, and that's perfect. So we're now going to get different values and density as we move up along our animation and in our timeline. So you can go in and be creative and create. You can even take this pattern further. But for this lesson, let's keep it simple and just trying to understand how animating the densities can give us these cool shapes. So I'll bring our container back up. Let's turn our drain geometry back on. Let's select our container. Now I'm thinking about changing the resolution from 100 to 150, and yes, let's go ahead and do that. And the reason I'm going to do this is because when we do a quick play blast, we just want to get a little bit more resolution so we can see how it's behaving in our viewport. So once this is done, I'll be right back.